So this is where we left off, and we want to write a Python script that shows the solution. And so what I'm going to do is I've opened up Spider, which is the basically editor and platform for implementing Python scripts. And what we'll do a little navigation here. What's left over up here is these are files that I've been working on recently. There's a file that's left on here. I just wanted to let you to see the structure over here in this panel is the code. If I hit F5, it runs the code, and there's lots of other things up here. We'll go through them one by one. The bottom right is a console, or this is where we can enter commands, so we can type in commands and say like x equals 2, hit enter, and then we can print x, and we can use this to check out various things. On the top right is, I forget what they call this region, but it's got several views. Outline doesn't do much. Help, you can look for help. Variable Explorer, this is very important. It shows all the variables, their types and size, and you can change what's visible and their values. And then the plots, whatever. If you have plots in your script, this shows what the plots are. Files, I don't use that much, but it's related. So these are the two things that I use all the time: Variable Explorer and plots. Okay, so what I want to do is close this file, or rather open a new file. Cancel that. I hit open. What I want to do is do a new file. So now there's a blank file, and it's a good habit as soon as I create a new file to save it as something. So I will save as. I will navigate to where I want to put it, and I'm putting it in this folder for Todd Hunter, and I'm going to call it Todd Hunter 1_1. You'll notice there's a Todd Hunter number 2, which I'm working on. So here's a basic blank file, Python file, and there's two ways to do comments. You can either do triple quotes with multi-line comments, and this is the blank. And so you add some text in here, so you can say something like program to simulate the mass on a roll to simulate Todd Hunter 1. And you should probably say more than that. If I go outside of that, the other way you can add comments is with the £, right? In MATLAB, it's the %, in Python, it's the £. And so I could say add. So what I'll do here is create a block of input parameters. I'm going to put a little space in here. You'll see I'm going to do something here, and I'm going to import from matplotlib. It pops up, and I'll select that, import star. Now what this is doing is it's saying I'm going to make some plots. While I'm here, before I get into that, I'm going to delete all the files that that were from previous, and I'm going to clear all the variables. You can't write code to clear variables in Python. I've looked for that, but you can't do it. So there's a couple different ways to import, but basically matplotlib is a set of functions that lets you make plots similar with similar commands to MATLAB. So what I often do when I'm in this place of wanting to implement a program and I have one screen is I do a split screen and I put the equations that I want to input over here and refer back and forth. So first thing that I like to do, and I want you to do going forward when you write script, is to every numerical problem you have has some kind of inputs that's usually in the problem statement. So in this case, we're going to say we just look at our summary slot, and we're going to need a big M, and so let's just say big M is equal to 10, and I'll put in a comment. So I'll tab space tab, put in a comment. I like to put in the units right here, comma, larger mass, and I'm going to put m little m equals 5 and kilogram, and call that the smaller mass. And then I look, and I'm going to need h. So let's put h. Let's decide on a height in meters. I'm going to work everything in SI units. So let's choose, I don't know, 1.5 as a somewhat randomly selected, but or let's just say 2.5. So that's like a initial height. It's really good to code, to comment code as you write it. And then what else do I have? Well, I have G. G is just a fixed parameter. I could maybe put in another category to organize things, but I'll put that in at the top, and that's not something that I'm going to change. Some of this is stylistic, and we'll just call that gravity. And we look through, and that's it, right? There's no other parameters in here. So now what I want to do is to create derived parameters. So a derived parameter, the input parameters are pure numbers, and derived parameters is some kind of calculation based on them. So I'll call it T star. I don't want to put a asterisk. Although actually, I'm gonna try that. I'm gonna go write T star. Now, here's a good habit. It's about time. I've entered things. A really good thing when you're coding is to run your code often. So I'm gonna hit F5, which is gonna run the code, and then I see over here it's telling me invalid syntax. So it doesn't like T star, as I suspected. But if I look at, so it didn't run because it had this error, and so you want to catch these bugs. So I'll call this T underscore star. Actually, maybe I forgot. I said T star equals 5. No, 5. So square root. I'm going to get an error here, but I'll explain that in a minute. M plus little m, I go out of the parentheses, times h divided by parentheses big M minus little m. When you type parentheses, it adds in parentheses, and then over, you'll get used to that, and then over G. And I think I have 2 errors in here. I'm going to run it. I've got invalid syntax, and I think that's because the star symbol means something very specifically. So I'm going to do underscore star, hit F5 to run it, and then I have square root is not defined. Oh, okay. So I'm going to be doing these math functions. I'm going to need to go in here, and from numpy, which is a library, I want to import. I could do import star, but it'll import 18 million things, and it's so okay. So I'm just gonna import the things that I need, and I'll add them as I need them. So I'm gonna import square root, and I know it's sqrt. So now if I hit run, it ran. There's no errors under here, and I have in my I have all my results up here, and I have a value for t star. So it's a float, whereas m is an integer and big M. And what I want to do is kind of fix that already. I want to put 10.0 and 5.0 just to turn them into floats instead of integers. And the default params in the list are things that don't mean anything, or they mean something, but not to me, and not for writing the code. But I have t star. I'm going to need v star, so I'll use little v star equals square root parentheses big M minus little m, go outside the parentheses, times g times h divided by parentheses big M plus little m. Hit F5 to just check I did that right, and I have v star comes up in here, and it's 2.859. Because of the way it's non-dimensionalized, this is this is very close to, it's not exactly, but it's going to be very close to t star. Is going to be the time it takes to fall. There's actually a square root of 2 going to be in there. V star is the characteristic velocity that it's going to do when I hit. If I change h to 250 and run it, I get 8 seconds and 28 meters per second as the speeds, but I'll leave it at 2.5. And then a star, I can put in the square root, but I can just a sub star, I'll just say is equal to v star over t star, and hit enter, and now we're good to go. So I'm going to stop the video here, just do this piece by piece and keep the videos short and sweet. And